Now that we have discussed several different ways of solving systems, so we had substitution, we have elimination, we have graphing, what's important is to know, well, when should you be using each one? Now, it's not that there's a right answer and a wrong answer. It's just that sometimes there's an easier choice and a more difficult choice. Any of the three methods will work every time. It's just that sometimes one method is easier than another. So let's take a look at some scenarios and see if we can decide what we think would be the easiest way to get things done. So let's take a look at the first one. Now, in deciding whether you're going to be using substitution, you want to see, is there a variable that's already by itself or that is easy to get by itself? Let's see what we have here. As I'm doing a quick look, I don't see anything easy to get by itself. Now, this y, for example, actually wouldn't be too hard to solve for. You could multiply by a -4, and that would give us the y by itself. It would still leave a fraction, which, while that's not bad, is sometimes harder to work with. So maybe substitution isn't the easiest way to go. As far as elimination, when you're making that choice, ask yourself, is it going to be easy to get things set up properly, to create that pair of opposites, so when we add the equations together, we eliminate a variable? I don't know. This is one that I describe as a little bit messy. And when the equations are a little bit messy, I personally prefer to graph them. I would graph this one, and then see where they cross each other. At that intersection is my solution, and I've saved myself that messy algebra work. So on this one, I think the best choice is going to be to graph it and see what happens. On this one, I would like you to do a quick pause, come up with what method or methods you think would be easiest: substitution, elimination, or graphing, and then unpause when you're ready to check. Okay, on this one, I personally think the easiest is going to be elimination. And I say that because the equations are already set up in their standard form, and all you have to do is multiply the top equation by -2, and you can eliminate the y's. That's not so hard to do. Now, if you chose substitution, that one's actually not so bad either. On the top, you could solve for either the x or the y just by dividing by 6. Everything is going to come out evenly. No fractions, that would work okay. And if you just personally prefer graphing, well, heck, this isn't hard to graph either, not with the way that our graphing calculators work. So while I personally would choose elimination, if you chose graphing here, I think that's a good choice. Or if you really like substitution, this one is good to substitute as well. Okay, again, quick pause. Unpause when you made your choices. Here's the key this time. I'm looking at the fact that I already have this y by itself. So I can just come down now into this second equation, and where I see the y, I can put this expression in where that y is and solve using substitution. So there's not a whole lot of work to do with the substitution method. Now, if you chose graphing, I think that's going to work okay too. This one is also not too bad to eliminate. You would have to move the -2x's over to this side by subtracting and then do some multiplying, but it's not like it's a super complicated process. But the easiest way, I think, is going to be substitution this time. Okay, make your choice here. I think that I would choose one of two, because as I'm looking at it, it wouldn't be hard to get this x by itself. Just subtract the 4y over. You'd have x equals -4y, and you can then substitute without too much trouble. It's also just as easy to multiply by 3 on the top equation, create a pair of opposite x's, and then eliminate as well. So on this one, let's say it's maybe a tie. Elimination would be easy, just multiply by 3 on the top. Or substitution because there's not a lot to do to get that x by itself. And of course, graphing is never that difficult. Um, but here I would probably personally eliminate and maybe substitute if I felt like it. Hey, once again, make your choice. So let's see here. Now, certainly, we can move terms over and then do a little multiplying to eliminate x's or y's. So elimination is going to work. However, it's not in that standard form. We don't already have things all on one side of the equal sign with the number on the other. So frankly, I think that I would graph this one. That way I can just type the equations in exactly as they look, see where those intersections happen, and at the intersection is the solution to the system. And here, this last one. Okay. Now, just because it's set up this way doesn't always mean that elimination is going to be the easiest. It often does. Let's see what happens here. If I think about substitution, getting this x by itself would leave me with a fraction. Getting this y by itself would leave fractions. The same is true down here for the x's and y's. So if I were trying to substitute, I would have to work with fractions. That's not bad. It is just sometimes a little bit more difficult. I think instead on this one, because it's already in this format, I would use an elimination. Maybe multiply the top equation by 3 and the bottom equation by -5. That would give me a plus 15x up here and then a negative 15x down here for that set of opposites. So when it comes to which method or methods are easiest, there really is no one way that's the best. I'm telling you here what my choices would be. But really, it comes down to this. And this is a good thing to include maybe on the back of your toolkit in that spot where you have extra space. So, is there a specific method you're asked to use? I mean, if it says to use substitution, you got to use substitution. If it says to graph, you need to graph. But if it doesn't specify a method, then it really comes down to your personal preference. I know some students, they just like to use elimination all the time. That way it's just the same steps every time, and they're very comfortable with that method. Whatever you like, feel free to use if it's not specified. If you're not sure what's easiest, take a look at your equations. Is there one equation that already has a variable by itself, or where it's super easy to get a variable by itself? If yes, then substitutions may be the way to go. If you're going to be using elimination, then I just want to hop back to the examples real quick. We use those in situations where the formats were already kind of set up, where it was already in that standard form, and you could create your pair of opposites just by multiplying. If so, elimination is the way to go. And if you have the option, quite frankly, I graph most of the time. That's the way, especially if the equations aren't simple. If they're messed around, or if they're big numbers, or if there are mixtures of decimals and fractions, then very often I think graphing is the best way to get things done. So with all that said, if there's a method specified, use it. But if not, it is going to be up to you.